In the previous session, we had discussed about the properties of the S matrix and how the condition for a network to be lossless. In today's session, we will see about the condition for a network to be reciprocal. So let's take a two-port network. I have a two-port network. This is my input A1, my reflected signal B1, A2 and B2 reflected signal. So what is the condition in this? The network is reciprocal in nature. Let's understand what is reciprocity, the physical meaning of reciprocity in the first place. Suppose if I have a low pass filter like this. Suppose I have a low pass filter and I feed an input at this end. Let's say this is L and this is L and this is C. This is a low pass filter and I give an input at this end and I take some output. Even if I reverse the network, I will get the same output. This is what I physically mean by a reciprocal network. And let us see what is the condition. That means given an input, you get an output. If I give the same input at this end, I should get the same output. So that means S21 should be equal to S12. S21 should be equal to S12. What is S21? What is the physical meaning of S21? 1 is the input and this is the output port. This is the input and this will be my output port. So if both these fellows are equal, that means the network is reciprocal in nature. Say if you, okay, so let's show that. Say I have a two-port network. Let me connect I give an input A1 to the network. This will be my reflected signal B1. Let's connect the output to a power meter. Perfectly matched condition. Perfectly matched. So what will happen? If I provide an input to A1, what happens? The power meter, there is a two-port network and the output of the two-port network, which will be nothing but B2, this will be B2, this B2 will enter into the power meter and the power meter will absorb all the power. So what will be the signal that is reflected back? There will be no signal reflected back. Am I right? Because you give a signal here, there is some process that is happening in the two-port network and you get an output as B2. The output B2 is entering into the power meter. So the power meter will absorb all the signal because it is under perfectly matched condition. So what is the reflected signal? A2, what will it be? A2 will be equal to 0. A2 will be equal to 0. So what will be S21 in this condition? S21 will be nothing but B2 by A1. S21 will be B2 by A1. Suppose if we do the inverse, suppose if I have a two-port network, the same two-port network, and I provide the same input here, say this is A2, and I take it at output B1, and the output, this fellow is connected to a power meter. Now what will be the reflected signal here? A1. Am I right? So you give an input A2, the signal is processed in the two-port network and it comes out as B1. The output is measured in a power meter. So all the signal is absorbed at the power meter. So because all the signal is absorbed by the power meter, no signal is entering back into the two-port network. So which means A1 will be literally 0. If A1 will be 0, S12 will be perfectly nothing but B1 by A2. Now if you compare both these fellows, naturally S12 should be equal to S21 because there is no signal that is being reflected back. Am I right? Because the power meter is under perfectly matched condition and all the signals will be absorbed by the power meter. So S12 will be equal to S21, which means Sij is equal to Sji, which is nothing but S is equal to S transpose. So if a network satisfies this condition, then the network is called as a reciprocal network. Then the network is called as a reciprocal network. It's a very straightforward derivation.